My name is Dr. Dianne Aronian. In my past life, I was an ophthalmologist, but today I feel compelled to tell you about age-related macular degeneration. Listen to me. What I have to say is suitable for people of all ages. Early detection of macular degeneration may save your vision. Let me tell you how. And also, let me tell you what. What is the macula? And what is macular degeneration? The macula is the most important part of the retina, and the retina is a network of nerves lining the inside of the eyeball. The macula, the size of a thumbtack, is host to 6 million photoreceptors called cones, responsible for detailed vision and color vision. The remaining retina holds 120 million rod photoreceptors that give us peripheral vision and vision in dim lighting conditions. With the passing of time, metabolic stress may harm these vital structures. This then is the essence of macular degeneration. According to the CDC, 50% of people over the age of 80 have some form of macular degeneration. 10% of those are legally blind. In the past, there was no effective treatment for the condition. Today, recent advances in the treatment of certain types of macular degeneration make it possible to control progression or even reverse damage if recognized early enough. As an octogenarian myself, I fit squarely in that 50% demographic. I would like to tell you about my own experience with macular degeneration in hopes that it may help you maintain your own vision. In addition, I'd like to tell you some amazing facts about the retina, the macula, macular degeneration, its treatment, and importantly, its prevention. My takeaway message will be, check the vision in either eye separately. And if you notice distortion or missing areas, consult an eye professional immediately. Here you see Ms. Cone and Mr. Rod checking their own vision. You ought to do that too. I want to stress the importance of early detection. The sooner visual distortion or disruption is recognized and treated, the more likely the chance for resolution. Listen, this is important. The eyes are connected in the brain, and the brain prefers to see a clear image as opposed to a distorted one. Looking through each eye separately makes the poor image more obvious. Here are a couple of cases in point. As you read on, you see that macular degeneration can come as a surprise. These people were losing vision right in front of their own eyes and didn't even know it. Don't let that happen to you. I retired from my practice of ophthalmology 20 years ago. And a year and a half ago, I noticed decreased vision in one eye. Straight lines were curved. As a professional, I knew this was probably a macular problem, and I went to my ophthalmologist who confirmed a diagnosis of early wet macular degeneration. I was horrified because my father had gone blind from macular degeneration, and there was nothing I could do to help him. The next day, I found myself in the office of a retinal surgeon. He injected a tiny amount of medication into my eye. And within 24 to 48 hours, the distortion was gone. quite miraculous. It's a year and a half later now, and with maintenance treatment, the distortion has not returned. Now, I am at the intersection between physician and patient. I feel qualified to raise awareness for the importance of early detection of macular degeneration. I want to spread the word, how easy it is to check the vision in either eye separately. Now I have some interesting facts to share with you. Here is a familiar sight, red eye from a camera flash. This is only reflected light from the interior of the eye, really no different than a roadside marker when a light hits it. But what is inside? My model eye here will help explain what is inside. You recognize the white of the eye, the sclera. It is like tough rubber, resistant and resilient. It needs to be because it is protecting the very delicate layers underneath. Just under the sclera is the blood supply, known as the capillary bed or choroid. It is responsible for the beautiful orange reflection you just saw, but more importantly for the care and nourishment of the retina, which is the third layer. The retina is the nerve center, the internal lining of the eye. You can also see where the optic nerve enters the eye and a mark, that yellow mark, designating the macula, the point of my lecture. Here is the real thing, as seen by an observer through an ophthalmoscope. You can see the optic nerve with its accompanying artery and vein, and nearby the macula in deeper orange. Here we see a model of the optic nerve coming into the eye as the forward extension of the brain. It is packed with millions of nerve fibers, or axons, which open out to make an extensive network of neurons terminating in the very specialized photoreceptors, the rods and cones. The cones, 6 million in number, are mostly concentrated at the macula, responsible for detailed and color vision, and the rods, 120 million in number, make up the vastly larger remainder of the retina. They provide vision in dim light and vision in the periphery. Here are a few microscopic specimens of neurons. They have round cell bodies with short fringes known as dendrites, and a long axon suitable to convey electrical impulses from one part of the body to another. In this case, from the eye to the brain. Let's look at the retina more closely. It is as thin as a piece of plastic wrap and just as flexible and clear, but much more likely to tear. It is made of those branching neurons which make a network covering the entire back of the eye. Neurons are constructed to carry an electric signal from one part of the body to the next. In this case, from the eye to the brain. After all the branching, there are 126 million terminals which end in a very specialized type of neuron, the photoreceptor, rods and cones. 6 million of the receptors are crowded together mostly at the macula. These are cones and responsible for detailed and color vision. The remaining 120 million rods, situated all around the back of the eye, are responsible for peripheral vision and sight under dim conditions. There are a few cones scattered among them. The outermost cell layer of the retina is the RPE, retinal pigment epithelium. I like to call it the nurse because it cradles the photoreceptors and is the middleman between the photoreceptors and the capillary blood supply. You see it here in green. Now, a better look at the rods and cones. This is an electron micrograph of rods and cones. You can recognize them by their shapes. Now an even more magnified picture of the business end of a rod. Note the stacked segments at the receiving end. They are made of molecules of a type of vitamin A and a protein called opsin, together called rhodopsin, the visual pigment. As you will see, a Pez dispenser makes a good model for it. To put size into perspective, the actual width of this rod outer segment is 2 microns. A human hair is 70 microns wide, so 35 rods could fit side by side on the width of a hair. This is how it works. Imagine that this Pez dispenser is the rod, and the candies inside are the segments. A ray of light comes and hits the top segment. That changes a molecular shift from cis to trans, not gender related, but positional. With that change, a tiny electrical spark is formed, travels down the length of the photoreceptor to the waiting neurons below, and on to the optic nerve and to the brain. Imagine that that tiny spark is a pixel in a digital picture. Imagine that 1,000,000 other tiny sparks are arriving at the brain, making a mosaic, a beautiful mosaic of moving vision. Meanwhile, back at the photoreceptor, the U segment is cast off, and the receptor makes a new segment that is placed at the bottom of the packet. Yes, the receptor does have a little factory inside. At the nurse, the U segment is sent to the capillary bed in return for new supplies. There is a lot of work to be done. In fact, at the junction of the photoreceptor, the nurse, and the capillary bed, the metabolic rate is the highest in the whole body per square millimeter. No wonder it begins to wear out. A word about blood vessel structure. Most large ones have 3 coats: an outside covering, the epithelium, a middle muscular layer to control blood flow, and a lining, the endothelium. As a vessel branches and gets smaller, it loses some of its coats, but a single layer remains, the endothelium. This scrunchie makes a good facsimile. Capillaries are made of a single layer of endothelium, which permits exchange of O2 and nutrients from the blood plasma, while wastes and CO2 are carried away by the bloodstream. Normally, a capillary is watertight, so small that blood cells have to go through one by one. The exchange happens by osmosis. As we age, the endothelium may get weaker and the exchange is less vigorous. This is how macular degeneration begins. There are 2 types of macular degeneration, wet and dry, often occurring together. We will start with the wet variety. Here again is our little cartoon. It looks like some photoreceptors have floated away from their nurse. Bad news. The endothelial capillary cells are leaking. This results in visual distortion, metamorphopsia, the same thing I experienced, the beginning of wet macular degeneration. Here is an Amesler grid. This is a self-test for people at risk for macular degeneration, often suggested by eye care professionals. Now, look at the white grid. Cover one eye without pressing on it. Keep focus on the center dot and notice if there's any warping of the lines on the grid in your peripheral vision, or clouded or missing areas. Metamorphopsia is the cardinal symptom of wet macular degeneration. Remember that this problem will worsen if not controlled as soon as possible, before bleeding and irreversible scarring occurs. Actually, there are straight lines everywhere in your environment. Even if you have 20/20 vision, the distortion can be detected. Just look for it with each eye alone. Notice the black grid to the left, showing an example of metamorphopsia. And now let me tell you about VEGF. VEGF is vascular endothelial growth factor, a protein naturally made by several different cells in the body in response to capillary endothelial damage. It promotes growth of new capillary vessels and is also important in development of the fetus. If you've been cut or wounded, VEGF comes to the site to help with healing. If there is breakdown of tissue from metabolic stress, VEGF comes to the rescue. However, it is a double-edged sword, because when it tries to repair damaged capillaries in the delicate choroid in the retina, the repair may be leaky. Plasma will be followed by blood cells, scarring, and loss of photoreceptors. Now we have an antidote, a treatment, anti-VEGF. Over the last 10 years, new antibodies have been developed in the lab against VEGF protein. When a minute amount is injected into the eye, it stops VEGF activity. Anti-VEGF is also effective in immunotherapy against certain malignant tumors and other eye diseases involving blood vessel growth. Medicine has advanced greatly since my retirement. Let me introduce dry macular degeneration. Now you see a picture of seborrheic keratosis, common in the elderly. Why do I show this? Because it is a sign of degeneration in the skin. Old cells are still hanging around. This reminds me of dry macular degeneration. In this picture, the drawing shows photoreceptors and the nurse RPE in good alignment, but there is some material between the RPE and the capillary bed. This probably represents old segments left behind, a sign of degeneration increasing with age. This is a slowly progressive change which signals metabolic stress. It may progress to geographic atrophy. This slide shows some of those accumulations known as drusen, as seen through the ophthalmoscope during a routine eye exam. The patient is probably asymptomatic and will be told that there are some common signs of aging in the retina. He or she will probably receive an Amesler grid to check for any visual changes. The second slide shows severe drusen threatening the macula, known as geographic atrophy. It causes decreased vision in poor light and may affect macular vision too. This may progress to wet macular degeneration as well. Treatment for dry macular degeneration is newly available. Its effectiveness is not yet proven because progression is usually slow. Now that you know something about the workings of macular degeneration, The keys to prevention should be obvious. Metabolic stress, otherwise known as oxidative stress, should be minimized wherever possible. First, protect your eyes from too much bright light. Sunglasses when outside and visors. Also, get as much rest and sleep as you can. For diet, leafy green veggies, colored fruit, anything containing lots of lutein and zeaxanthin, vitamins C, E, and A, zinc, and copper. These are all contained in seeds, nuts, salmon, sardines, and seafood for the minerals. Arid vitamins, which are specific for macular degeneration, are available as an alternative at drugstores or health food stores. Control blood sugar. And, very important, no smoking ever. I hope this overview has given you better understanding of macular degeneration. Please know that treatment is not a cure, but a means of prolonging the life of one of our most treasured senses. Vigilance and maintenance are required. Future advances may improve delivery and potency of medications, but remember, practicing preventive measures now may ensure excellent vision for you in the future. I wish that for you. Thank you for your attention.